Hi Sean, it's Pat Hoffheiser, and I'm going to demonstrate how we set up and solve dimensional analysis dosage calculation problems in nursing. I selected probably the most complex problem a student will face in nursing school, just so that you can see the length and breadth of it and how big the problems can get. I'm decided to show drag and drop first because I think that this is so engaging and really a great way to, particularly for introductory students in level 1 and level 2, to recognize the pattern and then do the calculation. So there's 3 stages to dosage calculation problems. 1 is they have to learn to decode the language of the problem. 2 is they have to learn how to set up the correct pattern, which at the lower levels is very basic and simple, so they think that they can solve the problem, but they can't because they didn't learn the pattern. So you have to learn the pattern so that when you get into these complex problems, you can set up the pattern correctly and numerically then solve the number correctly so that you get a safe, accurate dose. So that's the challenge. The numeric calculations is the last thing that we do. So the first thing we have them do is completely read their problem. So the context of our problem is a patient weighs 255 pounds. The patient is currently receiving dobutamine at 15 mLs an hour on the pump. Dobutamine is mixed 400 milligrams in 250 mLs of D5 and W. The question for the students is how many micrograms per kilogram per minute is the patient receiving? And then the last instruction is to round to the 10th place. So the first thing that the students should recognize is 2 things. Their question is in micrograms and their material is presented in milligrams. The question is in kilograms and their material is presented in pounds. So hopefully, as we educate them, they will know we're going to have to convert those 2 pieces of information with factors in order to get to the correct answer. And we train them that the factors are bridges to get you to where you want to go. So I set this up with pretty much a blank canvas at the top, just with the multiplication and the equal sign. So the symbols of the orders of operations are in there. And down at the bottom are composite blocks of information. Like here are all the units of measure. Here are answers, possible answers. 1 is correct, 1 is not. Here are all the possible numbers that they could use, and we could certainly add more numbers here as distractors. And over here are the possible answers for the numerator and the denominator before we do the division to get to the final answer. 2 are distractors, 2 are correct. So let's begin to set up our problem. The problem asked us to solve for micrograms per kilogram per minute. So we begin with that. So micrograms is in the numerator position, and then it is micrograms per kilogram per minute will be on the bottom of that fraction, and then it is equals. So if micrograms is on top, micrograms must be on top of the second fraction in the units of measure position. So this is a little bit of a Z pattern. When they begin, it is the 2 horizontals in the first fraction have to match. So micrograms equals micrograms. That's the logic that we teach them. Now eventually when they get much better at this, we can drop off the front part, but for right now they must see the logic of the problem. So they know they have to put micrograms here, but when they go back to the problem, there's, like we mentioned, there's no micrograms in the problem. So this is actually going to have to be their first conversion factor. So then they have to say to themselves, well, what is my conversion factor from micrograms? Well, that would be there is 1,000 micrograms in 1 milligram. And that's their first fraction, 1,000 micrograms over 1 milligram. They're going to multiply that times their next fraction. If there's milligrams on the bottom, they're going to have to put milligrams on the top. So they know that. So then they would go back to their problem and say, okay, where do I have milligrams in my problem? And that would be the 400 milligrams in 250 milliliters. Now, that is a solution that cannot be separated, so they have to stay together as a fraction. I'm trying to find my 250, there it is. Okay, now that fraction is correct, and milligrams would cross cancel out. The micrograms remains. Now I need to have milligrams on top of the next fraction because I've got milligrams in this fraction, so I would load that up. Go back to my question and say, well, where do I have milliliters? Okay, well, that would be the 15 milliliters per hour. Hour is going to go there, and it's 1 hour. I've set up this fraction, and I can cross cancel out my milliliters. So far, so good. I'm doing a good job. All right, so the next thing is hours. I've got hours here, but my question said I have to solve for minutes. All right, so I've got to get rid of that hour. So hour has to go on the top of my next fraction. This is going to be a conversion factor again, so I have to put in for every 1 hour, there is 60 minutes. Now my hours cross cancel out. So I have set up my problem correctly up to this point. I'm left with micrograms and minutes. That's the first part of my problem, micrograms and minutes. I've got those. I got to do something about this kilogram thing. All right, I need kilograms to be on the bottom. So to get that, I'm going to have to put a conversion factor in because in my problem, they gave me the patient's weight in pounds. So we got to put in our conversion factor. So pounds is going to have to go on the top. And it's 2.2 pounds. And then kilograms has to go on the bottom because I need kilograms to be on the bottom. And it's for every 1 kilogram. All right, so now my patient is weighed in pounds, and because pounds is on the top of this fraction, I have to put pounds on the bottom of this fraction, and the students understand that they can flip fractions. Patient weighs 255 pounds, and there is an understood 1 on top of that. We do have them put that in so that they can keep themselves straight and get the pattern set up correctly. All right, let me move over just a little bit because I want to see this at the end. Okay, so now the student has to go through and say, have I set my problem up correctly? Milligrams cross cancels, milliliters cross cancels, hour cross cancels, pounds cross cancels this way. I am left with micrograms, kilogram, minute. I can put the kilogram in front of the minute, and that's perfectly fine. So then they have to multiply all of their numerators together, and that's going to give them, they multiply that out. This is their top numerator position. Then they're going to multiply all of their denominators, and this is the number for their denominators. These are the 2 distractors. They're not correct. All right, so they got those correct. Now all they have to do is the math. They have to divide this denominator into this numerator. When they do that, they have 2 decimal possibilities down here. This is the correct one. Okay, so now they've got to the answer part, but now we need to finish it off. So the final piece was round to the 10th place. So down here, the students would have to select from these 2 rounded answers. Is it 3.0 or 3.5? And the correct answer is, it is 3.5 micrograms per kilogram per minute is their final answer. So you can see there's other distractors down here, and I think that that helps them so that they can't just guess at the right calculation. It's unlikely that they would be able to guess at the right units of measure. So then we need the computer system to identify that the student placed the correct units of measure into the correct positions first. And then the second step is that they did their calculation correctly and they rounded correctly at the end. And I do have all the rounding rules. I will try to add that to my communication to you of what are the nursing rounding rules. And I'll put the conversion factors in there too that we use for nursing. So that's the composite. I love the drag and drop because I think it really helps the student to be engaged. We can use the color coding. It just really helps them to see and different symbols how we can set this up. I don't know if all their drag and drop will do all that, but that's my big, great idea. Anyway, so I'm going to pause and move on to standard calculation. All right, moving right along. It's the same problem, and this is just a different, more standardized visual. So a patient weighs 255 pounds. The patient's currently receiving dobutamine at 15 mLs per hour on the pump. Dobutamine is mixed as 400 milligrams in 250 mLs of D5 and W. The question posed to the student: how many micrograms per kilogram per minute is the patient receiving? Round to the 10th place. So here I've set up a series of fractions, whether or not I need them all, and that one's not complete, so let me fix that. All right, let's hope we can get through this. My Word keeps not responding. All right, so we read the problem, and we're going to begin to set up now. So we have micrograms is what we are asked for, kilograms per minute. All right, so if there's micrograms on the left of the equal sign, we must have micrograms to the right. So that, again, I don't have to go through all the same instructions again, but that tells the student, oh, I need to do a conversion factor before I can actually get to my calculation. So this would be 1,000 micrograms is in 1 milligram. The next part of the problem, if they've got milligrams on the bottom of the first one, they're going to have milligrams on the top of the second one. And the next piece of information they have is 400 milligrams, which is in a solution of 250 ml, so those have to go together. If there's mLs on the bottom of that one, there's got to be mLs on the top of the next fraction. So then they go back to their question and find where else in my question do I have information about milliliters, and that would be the 15 milliliters per 1 hour. All right, so far so good. Cross cancel milligrams, milligrams, cross cancel milliliters, milliliters. That's great. All right, so they're good up to this point. And the next, oh no, they're not. They got to get rid of that hour. All right, so they have to convert to minutes because the question wanted it in minutes. So they're going to have to put in, if there's hours on the bottom of that one, there's got to be hours on the top of the next fraction. And that's in 60 minutes. That's going to cross cancel their hours. All right, so now they have remaining micrograms and minutes, which they've got micrograms and minutes. We still need the kilograms, but our patient is in pounds. But to get to pounds, we're going to have to do a conversion because we need the kilograms to end on the bottom. So our kilograms is going to go on the bottom and our pound is going to go on the top. This is going to have to be a conversion factor. So the students know that there's 2.2 pounds in every 1 kilogram. All right, the patient weighs 255 pounds. And they know that that is an understood 1 up there. So now what the students are instructed to do is multiply all their numerators together, then multiply all their denominators together. Yes, we do teach them. You can do your numerators and then 1 by 1 on the calculator, do your denominators. But in the beginning, that is really too much for them. And when they do that calculation, they get their numerator, they get their denominator, and then they're instructed to do the math. Divide that denominator into that numerator. And when they do that math, they get 3.4509. The instructions were to round to the 10th place. And when they round to the 10th place, they get 3.5, and that is micrograms per kilogram per per minute, which is what the question asked us. So now they have the correct answer to the problem. So again, it is decoding the problem, setting up the correct units of measures following the correct pattern, cross-canceling, matching units of measure, inserting their known conversion factors correctly. And once they have all that, they should be able to pause and verify that they've crossed out everything except what the question was asking for. And then they just do the math, which is basic math, multiplication, division, and then rounding, following the rounding rules. And I will supply the rounding rules for you. I hope that makes sense. I'm very happy to answer any questions or to add more details or specifics, but those are the phases of dimensional analysis, and that's probably one of the biggest problems a student could get. All right, thanks, Sean.